Lake Travis is disappearing, and Austin just declared a water emergency. Right now, engineers are drilling 400 feet into the earth beneath one of Texas's most iconic lakes, not to build something new, but because the old system is failing. The pumps that have supplied water to over 2 million people for decades are in danger of running dry. Literally. During the worst droughts, the floating pump stations that pulled drinking water from Lake Travis came so close to hitting the exposed lake bottom that engineers panicked. So Austin is going deeper, emergency deeper. But here is the part that nobody is talking about. The Highland Lakes, the entire chain of reservoirs that Central Texas depends on, haven't been full since 2019. The lake has been so low that things buried underwater for decades have resurfaced. A concrete plant, ancient pecan groves, a ghost landscape rising from the mud. And the terrifying truth is this. No matter how deep Austin drills, the water has to actually be there. So with a booming population, a punishing sun that evaporates as much water as an entire city drinks, and droughts that keep getting longer and more brutal, is Austin already running out of time? Lake Travis did not appear by accident. It was built by human hands, by a government that understood one brutal truth about Central Texas. Without stored water, this land could not support a civilization. In the 1930s, 40s, and 50s, the U.S. Army Corps of Engineers and the Lower Colorado River Authority built a chain of dams along the Colorado River, carving 6 lakes into the Texas Hill Country: Lake Buchanan, Lake Inks, Lake LBJ, Lake Marble Falls, Lake Travis, and finally, Lake Austin. Together, they form the Highland Lakes system, one of the most important pieces of water infrastructure in the entire American Southwest. But not all 6 lakes are created equal. Most of them are what engineers call pass-through lakes. They collect water, hold it briefly, and move it downstream. They keep the river system balanced. They generate hydroelectric power. They give Central Texas its scenery and its recreation economy. But they are not the ones keeping the taps running. That job belongs to 2 lakes, Lake Buchanan in the northwest and Lake Travis closer to Austin. These are the storage reservoirs. These are the ones that matter when the rain stops coming. Every drop of drinking water that flows into Austin, Cedar Park, Round Rock, Leander, and dozens of surrounding communities traces back to one of these 2 lakes. Combined, they are the water supply for over 2 million people. The system works like a chain. Water falls as rain across the hill country. It flows into rivers and creeks, filling Lake Buchanan first. From there, it moves downstream through the smaller lakes, each one passing water to the next, until it reaches Lake Travis. Lake Travis sits at the bottom of that chain, the last major reservoir before the Colorado River continues toward the Gulf of Mexico. When Lake Travis is full, the system is healthy. When it starts dropping, alarms start going off across every water management office in Central Texas. The entire system was designed in a different era, for a different climate. Engineers in the 1940s built it to handle the rainfall patterns of the 20th century. They built it to survive tough years. They built it for a region that was growing, but growing slowly. They did not build it for a metro area pushing toward 4 million people. They did not build it for summers that now regularly push past 100 degrees for weeks at a time. And they absolutely did not build it for droughts that don't last a season, but last a decade. For generations, the Highland Lakes delivered. The system held. But the climate that the system was designed for no longer exists. And the consequences of that mismatch are now impossible to ignore. The warning signs did not arrive suddenly. They built slowly, year after year, like a lake that drains 1 inch at a time until the day you look out and realize the water is gone. It started with the drought of 2008. That year, rainfall across Central Texas began falling below normal. Creeks that had run reliably for generations went dry. The hill country ground, normally quick to shed water into rivers and lakes, turned hard and cracked. Rain that did fall got swallowed by parched soil before it ever reached a stream. Inflows into the Highland Lakes collapsed, and the lakes began to drop. They kept dropping for 8 years. By the time the 2008 drought finally broke in 2016, it had become the worst drought ever recorded in the Austin area. Not in recent memory, not in the modern era, ever. It surpassed the catastrophic drought of the 1950s, which had itself been considered a once-in-a-century event. Cities across central Texas were forced to scramble, moving water intakes, hunting for backup supplies, and imposing restrictions on millions of residents. Lakes Travis and Buchanan fell to just 1/3 of their total capacity. The system did not fail, but it came closer than anyone was comfortable admitting publicly. Then came brief relief. Rains returned, levels climbed, but the lakes never fully recovered, and the respite did not last. By the summer of 2023, the combined storage of Lakes Travis and Buchanan had dropped to 44% of capacity, the lowest point in a decade, after another season of record-breaking heat and almost no meaningful rainfall. Lake Travis alone sat at 41% full heading into the summer of 2024, despite some spring storms that briefly raised hopes. And every single summer, the same silent enemy shows up and takes its cut. Evaporation. The sun and the wind pull water off the surface of Lake Travis at a rate that consumes as much water as the entire city of Austin uses in the same period. It is the largest single draw on the system. It cannot be managed. It cannot be negotiated with. It just takes, every day, without stopping. The LCRA responded the only way it could. Stage 2 drought restrictions were triggered in August, when combined lake storage fell to 45% of capacity. Outdoor watering cut to twice a week. A 10% reduction in overall use requested across the region. Stage 3 sits at 30%. Stage 4 is the level nobody wants to say out loud, because Stage 4 means the emergency is no longer theoretical. The lakes were draining, and the pipes built to pull water from them were about to reveal a problem that made everything worse. For decades, the answer to the question of how you pull water from a lake was simple. You put a pump on a barge, float it on the surface, and let the water come to you. It was practical. It was cost-effective. And for most of the 20th century, it worked. The Brushy Creek Regional Utility Authority, a partnership formed in 2006 between the fast-growing cities of Cedar Park, Round Rock, and Leander, relied on exactly this system. Their floating barge pump stations sat anchored in Sandy Creek Cove, a relatively deep inlet on Lake Travis. As the lake level rose and fell with the seasons, the barges rose and fell with it. The pumps kept pulling, the water kept flowing, the cities kept growing. Then, the droughts got serious. During the worst years of the extended drought cycle, lake levels fell so far and so fast that the floating barges began doing something engineers had never seriously planned for. They started sinking toward the bottom, not because they were damaged, not because anything had broken, but because the lake itself was disappearing beneath them. The water column that kept the barges afloat and the intake pipes submerged was shrinking. In Sandy Creek Cove, which had always been considered deep enough to provide a safety margin, that margin was evaporating. At the lowest points, the barge pump stations came dangerously close to grounding out completely. If that happened, if the barges hit the lake bed, 3 cities would lose their primary source of raw water. Not in some distant worst-case scenario. In the immediate, practical, near-term future. The system that had been built to serve a booming region was within striking distance of simply stopping. And it was not just the barges. The retreat of the water revealed something that shook people who had lived near Lake Travis their entire lives. As the lake dropped to levels not seen in decades, the past began to resurface. An old concrete plant that had been submerged for years emerged from the mud. Ancient pecan groves that had drowned when the dam was first built reappeared, their skeletal trunks rising from the exposed lake bed like something out of a nightmare. The landscape looked less like a reservoir and more like an archaeological site. The water that was supposed to be there simply was not. This was not a temporary inconvenience. This was a structural failure of assumptions. The entire intake system had been engineered around a lake that was expected to stay relatively full. Nobody had built it for a lake that could spend years at 40% capacity and still be dropping. The barges had been the plan. The barges were no longer enough. Something had to change. When the barge system nearly failed, engineers did not patch the problem. They went back to the beginning and asked a harder question. What would it take to pull water from Lake Travis, no matter what the drought does to it? The answer they came back with was extraordinary. Go deeper, much deeper. The Brushy Creek Regional Utility Authority had already completed Phase 1 of a long-term solution back in 2012 at a cost of $190 million. That phase delivered the interim floating pump stations and a 78-inch diameter pipeline stretching 5.1 miles from the lake to the regional treatment plant. It was a major achievement, but the floating stations were always meant to be temporary. They were a bridge to something far more permanent and far more resilient. Phase 2 is that permanent solution. Construction began in 2022. The price tag is $250 million, and the scale of what is being built beneath the surface of Lake Travis is almost difficult to comprehend. 2 fixed intake structures are being anchored near the absolute deepest point of the lake. A tunnel, 11 feet in diameter, is being bored nearly 2 miles through solid earth at depths reaching 400 feet below the surface. A raw water pump station on the shore houses a main shaft that descends 300 feet straight down, 32 feet across, driven by submersible pumps producing up to 3,600 horsepower. When it is finished, the system will be capable of delivering 145 million gallons of water every single day. The engineering challenges alone read like a list of everything that can go wrong on a construction project. Narrow, winding roads that could barely handle large equipment deliveries. An endangered species preserve requiring years of permitting. Shafts being sunk directly beneath the lake floodplain. And a power demand so extreme that more than $25 million had to be spent on electrical upgrades alone, including 10 miles of new overhead lines and 100 separate land easements just to keep the lights on at the construction site. The target completion date is 2027. The floating barges will be retired. And for the first time, Cedar Park, Round Rock, and Leander will be able to pull their full water supply from Lake Travis, even at the bottom of the worst drought on record. Managing the Highland Lakes is not a job for the faint-hearted. The Lower Colorado River Authority sits at the controls of a system that has to solve 2 completely opposite problems at the same time. Too little water and 2 million people lose their drinking supply. Too much water and communities downstream face catastrophic flooding. The margin between those 2 disasters is smaller than most people realize. The LCRA operates the floodgates at Mansfield Dam and across the other Highland Lakes dams, controlling how much water moves through the chain at any given moment. During drought, the strategy shifts toward conservation. The authority begins drawing more heavily from Lake Buchanan in the northwest, trying to preserve whatever remains in Lake Travis closer to Austin. But Buchanan has its own limits, and when both lakes are stressed simultaneously, the options get very narrow very fast. In April 2024, the LCRA adopted an updated drought contingency plan with stricter triggers and more aggressive response measures at every stage. Stage 1 restricts outdoor watering and requests a 10% reduction in use. Stage 2 tightens that further. Stage 3 activates at 30% combined capacity, imposing severe cuts across the entire system. Stage 4 is the level where conventional water management ends and emergency measures begin. One of those emergency measures is a strategy called indirect potable reuse, a process that takes highly treated wastewater, moves it into Ladybird Lake, and then retreats it to full drinking water standards. It is the kind of option that sounds extreme until the alternative is running out of water entirely. The LCRA has been direct about the pressure the system is under. Their own officials have said publicly that the agency has been operating in reactive mode. That is a remarkable admission from a public utility responsible for the water security of one of the fastest growing regions in the United States. Central Texas is adding residents at a pace that strains every projection. More people means more demand. More demand against a shrinking supply means the tightrope gets thinner every single year. The plan exists. The restrictions are in place. But the gap between what the system was built to deliver and what the region now needs grows wider with every dry summer that passes. Austin has never been a city that ignored a crisis once it became impossible to ignore. When the 2008 drought began draining the Highland Lakes year after year, city officials did something that most municipalities never do. They started planning not for the next 5 years, but for the next 100. The Water Forward Plan was born out of that drought. First adopted in 2018 and significantly updated in 2024, it is Austin's formal acknowledgement that the Highland Lakes alone cannot guarantee the city's water future. The plan does not pretend otherwise. It lays out in clear terms that the system serving 1 million people today will need to serve 4 million people within a century, and that the climate those 4 million people will live under will be harsher, drier, and more unpredictable than anything the 20th century produced. The plan attacks the problem from every direction at once. Conservation is treated not as an emergency response, but as a permanent way of life, something built into how the city operates every single day, regardless of lake levels. Water reuse systems are being expanded to reduce how much treated drinking water gets used for purposes that do not require drinking water quality. An aquifer storage and recovery project is underway, designed to pump surplus water underground into the Carrizo-Wilcox Aquifer in Bastrop County during wet years and pull it back out during droughts. Storing water underground eliminates the evaporation losses that bleed the surface reservoirs dry every summer. An off-channel reservoir is being planned to capture Colorado River water during high flow periods for storage and later use. And in the most severe drought scenarios, Austin has a last resort option called indirect potable reuse. Highly treated wastewater would flow into Ladybird Lake and be retreated to full drinking water standards. It is planned to be online by 2040. Scientists at the University of Texas are building climate models that push further than any previous projections, incorporating the latest international climate data to map out exactly how bad the droughts could get and how fast the city needs to move. The plan is serious. The investment is real. But climate scientists are increasingly warning that the timeline may be tighter than even the most aggressive projections assume. The drills are still turning. 400 feet beneath the surface of Lake Travis, the tunnel boring continues around the clock, carving through rock and earth toward a completion date that is still 2 years away. The deep water intakes are not finished. The aquifer storage project is not finished. The indirect potable reuse system will not be ready until 2040. And the next drought does not care about any of those deadlines. This is the gap that keeps water managers awake at night. The solutions are real. The engineering is sound. The funding is committed. But infrastructure of this scale takes years to build, and the climate is not waiting. The same models that failed to predict the intensity of recent droughts are now projecting conditions that grow more severe with every updated dataset. The window between when the solutions are needed and when they will actually be ready is not guaranteed to stay open. The population pressure makes that window smaller every year. Central Texas is one of the fastest growing regions in the entire United States. Every new subdivision, every new business, every new resident added to the Highland Lakes service area increases the daily demand on a system that is already being pushed beyond the assumptions it was designed around. Conservation helps, restrictions help. But conservation alone cannot close a gap that is being driven by both climate and demographics simultaneously. What the story of Lake Travis ultimately reveals is something uncomfortable and important. The infrastructure that built modern Central Texas was extraordinary for its time. The dams, the reservoirs, the pump stations, the pipelines, they represented generations of engineering ambition and public investment. They worked. For decades, they worked beautifully. But they were built for a world that no longer exists, serving a population that has doubled and redoubled under a climate that has fundamentally shifted. Austin is drilling deeper because it has to. Because the old depth is no longer enough. Because the lake that the city was built around is no longer the reliable, steady presence it once was. The only question that remains is whether deeper will be deep enough. There is a version of this story that ends with reassurance. The tunnels get finished. The aquifer fills up. The rains return on schedule. The population growth levels off. The climate stabilizes. Austin turns on its taps in 2030, and the water flows clean and cold and unlimited, the way it always has, the way most people still expect it always will. That version of the story is not supported by the evidence. What the evidence shows is a city in a race. On one side, an extraordinary mobilization of engineering, planning, and public investment. Deep water intakes being bored through solid rock. Aquifers being studied and mapped across 8 counties. 100-year plans being written and rewritten as the climate data keeps shifting the goalposts. On the other side, a set of forces that do not negotiate. A sun that evaporates water faster than a city can conserve it. Droughts that last not seasons but decades. Floods so sudden and savage they kill 100 people in a weekend and still cannot be counted on to refill the lakes reliably. A population that keeps arriving, keeps growing, keeps demanding water that the system was never designed to provide at this scale. The Highland Lakes have sustained Central Texas since the 1940s. Lake Travis has been the anchor of that system, the reservoir at the bottom of the chain that everything else depends on. For generations, it delivered. It held through hard summers and bad years, and periods when the rains were slow to return. It was enough. The question that Austin's engineers, water planners, and climate scientists are all quietly grappling with right now is whether enough is still possible. Whether the combination of deeper intakes, underground storage, reuse systems, and aggressive conservation can outrun what the climate is becoming. Whether a city of 4 million people can be sustained by a river system designed for a fraction of that demand in a climate that barely resembles the one the dams were built for. The drills are going deeper. The lakes are still shrinking, and 2 million people are waiting to find out which one wins.